Okay, this is part 3 of lesson 2.1, and in this video we're going to find the equation of a right bisector. But first, what's a right bisector? Well, a right bisector is a line that's perpendicular to another line intersecting at the midpoint. So, I'm going to graph what a right bisector looks like. We're going to use our knowledge of geometry and lines to come up with some steps, and then we're going to follow the steps to get an equation. So let's first look at a right bisector. Two schools are located at points P and point Q. Point P is negative 1, 4. So if I graph that, that would be right here. And point Q is 7, negative 2, which would be right here. The school board's planning a new sports complex to be used by both schools. The board wants to find a location equidistant from the two schools. Use an equation to represent the possible locations for the athletic complex. Well, that equidistant part is pretty important here, because if we have P and Q, we could use the midpoint, the point right in the middle. And if we found the midpoint, that could be one possible answer. But another group of answers would be really anything. If I put my ruler up here, I could maybe go like this. Let's see if that looks good. Yeah, pretty good. Really anything along this line that's perpendicular through the midpoint would be equidistant from P and Q. So like if I pick the point up here, it would be the same distance from here to Q as it would be from here to P. So really anything along this line. And this line's called a right bisector. So the line, the right bisector, is going to go through the midpoint of PQ, and it's going to go through it at a right angle. So we can use that knowledge to come up with some steps for how we might find the right bisector. First things first, though, we need to find the midpoint of PQ. So let's find that first, because then we can draw an appropriate right bisector. P and Q, I got to keep those points up there. P is negative 1, 4, and Q is 7, negative 2. And if we remember, so step 1, our midpoint our equation for midpoint said that if we add the x's and divide by 2, add the y's and divide by 2, we get the coordinates of our midpoint. Well, instead of writing out the equation, let's just do that. Let's add our x's and divide by 2. Our x's are negative 1 and 7. And we're going to divide by 2. Our y's are 4 and negative 2. And we're going to divide by 2. As you get a little bit more efficient with calculations like midpoint, you don't have to write the equation out every time. Once you learn how to use it, you might just go right to putting the numbers in, because you remember, I'm just adding the x's, dividing by 2, adding the y's, dividing by 2. And we end up with a midpoint. Our midpoint is 6 over 2, which is 3. And 4 minus 2 is 2, divided by 2 is 1. Our midpoint is 3, 1. So if I go put that on the graph, 3, 1, there's our midpoint. So our right bisector is going to go through this point at a right angle. Well, if we want the equation of this line, all we know right now is a point on the line. We only know 3, 1. We don't know anything about the slope or the y-intercept. We could graph it, and that could kind of help us come up with a slope and a y-intercept, but it might be wrong because we don't know how to graph a perfect right angle. So what we might want to do instead is find the slope of PQ, because if we do the negative reciprocal, we find a perpendicular line. And that goes back to our review of grade 9 in 2.0 lesson, perpendicular lines. So we're first going to find the slope of PQ, and we're going to use that to find our slope of right bisector. And we can do that because the slope of PQ and the slope of the right bisector will be negative reciprocals. So it'll be the negative reciprocal of what we get in step 2. So let's find the slope of PQ. To find slope, that would be little m. And I'm going to put PQ here so we know that this is a slope of PQ. And it's y2 minus y1. So up to my points, y2 is negative 2, y1 is 4. So it's negative 2 minus 4 over x2 minus x1 is 7 subtract negative 1. Back down. 7 subtract negative 1. And we get negative 6 on top over 8 on the bottom. If we reduce that fraction, we get negative 3 over 4. And there's our slope of PQ. Now, that's not the slope of our right bisector. The slope of our right bisector is the perpendicular slope. And the perpendicular slope is the negative reciprocal. So our slope of PQ is negative, so our slope of our right bisector is going to be positive. Slope of PQ is 3 over 4, so our reciprocal would be 4 over 3. Now we know the slope of our right bisector, and we have a point. Slope and a point means we can find B. So step 4, find equation right bisector. Step 4. Equation of right bisector. Like all lines, it's going to be y equals mx plus b. So start with y equals mx plus b. What of this information do we know about our right bisector? Well, we know the slope is 4 over 3. We don't know the y-intercept, but we know the point 3, 1. 3 for x, 1 for y, plus b. Now normally, I would say multiply this whole equation by 3 because that'll help you get rid of the fractions. But this time, conveniently, something nice happened. 4 divided by 3 times 3. When we multiply this fraction by 3, we're going to get rid of the denominator already, so we don't have to clear the fractions because 3 divided by 3 is 1. So that fraction goes away, and we end up with just 4 plus b is 1. Subtract 4 from both sides, or move the 4 to the other side, make it negative. We get 1 minus 4. 1 minus 4 is negative 3, which is b. And now we know b. We found the slope earlier, so now we can write the equation. Therefore, y equals 4 over 3x minus 3. And that's the equation of our right bisector. So, to recap, we've got our steps up here. And this example followed through all 4 of those steps. What's our right bisector look like? Well, it went through the midpoint. It had a y-intercept of negative 3. I'm going to put negative 3 on there. The question didn't tell us to graph it, but for completeness, let's look at what that line actually looks like. And that equation was 4 over 3x minus 3. There's our right bisector. And that means that any dot on this line is the same distance from P as it is from Q, which is kind of neat. And that's the application of a right bisector, finding points that are equidistant from 2 other points. All right, that's it for lesson 2.1. Thanks for watching all 3 parts, and I'll see you next time.